Precalc 7.3. We're going to do more trig identities here. We're going to finish up. This is the last lesson of the trig identity stuff. They're only going to get more complicated or just more things that you have to know. Like I said earlier, I'm not going to have you guys memorize all of these. We will have the note card on the back of the unit circle to put them on there. You guys will be expected to recognize patterns, recognize which ones to use at what time. So these are called double angle formulas. So we're going to actually prove one of them, and the others are going to be basically the same idea. We got ones for sine of 2x, cosine of 2x, and tangent of 2x. Sine of 2x and tangent of 2x, guys, only have one option. Sine of 2x is 2, sine of x, cosine of x. But if you go to tangent of 2x, again, you only have one option. Cosine of 2x, though, ends up having 3 different versions. So instead of the book going cosine of 2x here and here, they just leave it as 1. But all 4 of these things, technically, are equivalent, which means that you can use any of them. So let's talk about at least proving one of these to show that it does work and that the others can be found the same exact way. If I had sine of 2x, what's another way of writing sine of 2x?
Cosine, sine over cosine.
Not sine over, you can't do sine over cosine. That's not sine, that'd be tangent. Wouldn't you guys agree that that would just be x plus x? And do you guys know the addition formula for sine? Sine of x cosine x plus cosine x sine x. Hey, wait a minute. Those are the exact same thing, just different order for multiplication. That's fine. And if I have 2 things added together, I have how many of them? 2 of them. So now we just proved that first identity. The rest of them can be handled the exact same way. Obviously, cosine, there's a couple ways that you guys can move things around, change things up, that ends up resulting in those 3 answers that they're okay with. And then tangent of 2x, you can do the same thing. Okay, so how are am I going to be expecting you guys to use the double angle theorem, not only to prove things, which is coming up next, but what if I tell you that cosine of x is equal to negative 2/3 in the second quadrant? Can you find just cosine of 2x and sine of 2x? So instead of trying to figure out what x is itself, we're going to use the fact that cosine of that angle x is a negative 2/3. I should then be able to find the other 6 trig functions. Would you guys agree? We had to do that in our last test. We know that we got this triangle in the second quadrant. There's x, and we're doing cosine. Cosine was negative 2 and 3. It's amazing, guys, on your last quiz, how many people added the hypotenuse to a leg instead of subtracted. They ended up with like 55, or square root of 55 instead of square root of 40. So, several people in every class did that. But to do this, you'd be like, oh, that's 3 squared minus negative 2 squared, and that'll equal y squared, which is here. 9 minus 4 is 5. So it's the square root of 5, right? At this point, you should be able to tell me the sine, cosine, tangent, and their reciprocal functions of x. Okay, that's old news. That's old news. What I do need, though, is I want you to tell me cosine of 2x. I want you to tell me the sine of 2x. And you know what? It's not on here, but what is the tangent of 2x as well? So what I tell you to do, or I suggest that you do, is go back to your notes, boom, and instead of sine of 2x, write 2 sine x cosine x. I could fill those in. Down here, I can choose any of these three. And in the last one, I can choose this one. Yes, you should. Now, I think the easiest one, sine of 2x is 2 sine of x cosine x. Tangent, or cosine, you do have three options. And all three options are perfectly fine to do. But think back to when we were working with our triangles and using the law of sines, law of cosines, and all that. Or even just triangles with similarity and side ratios from last year. If you are given numbers to solve a triangle, did you want to use, once you found, like we found square root of 5, do we really want to use square root of 5? I mean, I think we all can sit back and agree that square root of 5 is right. But can we really guarantee that square root of 5 is right? Not necessarily. I mean, if we did our math right, it should be. But if you have options to use numbers that were given to you, wouldn't you want to use the firm numbers instead of numbers that you're finding? Because somebody would not write square root of 5, and I don't know why, but instead they would write 2.36985, right? They'd use the approximation or whatever it is. And at that point, are you going to get the same answer as somebody else?
No.
No, you're going to get approximations. So you're better off using numbers that you know are concrete and real versus ones that you found. So what I'm doing all of this for, is that cosine has three options. Look, there's three options. Which one of those three options is going to lead you in a direction of using numbers that you absolutely know? Number 3, the last one. Because the last one only deals with cosine. You were given the answer or the problem in a cosine. So I would choose 2 cosine squared x minus 1. Tangent, you only have one option. And remember, that one was 2 tangent x over 1 minus tangent squared x, is it? Then what it comes down to is just your algebra. How good are you at your algebra? Playing coach and evaluate. So, hey, what was cosine again? Negative 2/3. What happens when you square a negative? So this becomes 2 times 4/9 minus 1. Or 8/9 minus 9/9. Or negative 1/9. Can you guys follow what I did there? I was subtracting 1, so I changed it to a 9 over 9. Good common denominator, so I can do this. I could care less what x is. I wasn't asking you what x was. What I am asking you is, what's the value of cosine of 2x? Knowing that cosine of x was negative 2/3. Okay, do the same thing for sine of 2x and tangent 2x. 2 times cosine was a negative 2/3. That's easy enough. What is sine of x? Square root of 5 over 3. And you end up with negative 4 square root 5 over 9. Question. What quadrant are we in? The sign should be positive. Why is it negative? Are we really in second quadrant?
No.
Why? The second quadrant is where angle what is? x. We're doubling x. So if you happen to be in the second quadrant, any angle in the second quadrant, you double it, you're going to end up at least in quadrant what? 3 to 4. So therefore, sine would have to be negative. That's why it makes sense. That's a lot of information that we're putting together, right? We dug all the way far back into all students take calculus. We're actually this whole idea of reference angles and all this stuff that are the same. That's pretty cool. Hopefully there's enough room here. 2 times tangent is square root of 5 over negative 2 over 1 minus square root of 5 over negative 2 squared. I am running out of room. Let me pause. So then, now we can keep going. Ooh, 2 divided by negative 2. Isn't that just negative square root of 5? Because the 2's will cancel. Okay. And then it's 1 minus. Oh wait, should that be positive or a minus? There's a negative inside. There's a negative on the outside. They'll cancel each other, right? I got to square it first. And when I square a negative fraction, it becomes a positive fraction, and that becomes 5 over 4. Oh, that's just 4 over 4. So this is negative square root of 5 divided by negative 1/4. 2 negatives now make a... Oh, that should be a square root of 5. So this ends up being 4 square root 5. Done. If we did not want to use the double angle formulas for tangent, you could do the sine of 2x over cosine of 2x. You do end up at the end, if you notice, negative 4 square root of 5 divided by 9 over negative 1/9. The negatives cancel out, the 9's cancel out, so therefore you're left with 4 square root of 5. Same thing. Good observation. Okay, triple angle formula. I want you to write cosine 3x in terms of just cosine, nothing else. Using the exact same, we don't have a triple angle theorem or formula. So using the same idea we went to go prove that sine of 2x worked, can we split up 3x? Are you guys okay with that? Which then would lead us to cosine 2x cosine x minus sine 2x sine of x. That's the addition formula for cosine. And at this point, now we can fix cosine 2x sine of 2x. Everybody okay with that? Notice that there's going to be a cosine attached to the first group, and there's going to be a sine attached to this group because they're on the outsides. I got a question. We want the answer to be only in what? We want it only in cosines. Cosine of 2x has 3 options. 2 of those options have a what in it? A sine. Do we want to introduce sine where we want cosines? No. So we'll use a third option again. And the third option again was what? 2 cosine squared x minus 1. And the sine of 2x is 2 sine x cosine x. Everybody's okay with that? Yes? Can you distribute the cosine in the first group, distribute the sine in the second group? 2 cosine cubed x minus cosine x. Ooh, can you guys do this at the same time? This negative needs to be distributed in, and sine needs to be distributed in. Is that okay? So that's a negative 2 sine squared x cosine x. We done? Not quite, because now we have a sine squared. The rest of it's fine. They're all of cosine x's. Cosine cubed of x is still cosine x, but it's cubed. That's fine. What is sine squared equal to? 1 minus cosine squared. So this stays fine. But now, I have to change out sine squared. And again, this one's a little bit trickier because now you have actual polynomial inside the parentheses. Are you guys okay with the -2 being distributed in? And at the same time, the cosine. So it'd be -2 times 1 times cosine. So that's a -2 cosine x. A -2 times negative cosine squared times cosine. Oh, there should be a 2 in front, right? So 2 cosine cubed of x. And all the thing that's left to do is gather up like terms. And you probably put in standard form, highest to lowest power. So you end up with 4 cosine cubed of x minus 3 cosine x. Done. The next one is now we're going to prove an identity. Prove one side looks like the other side. Sine of 3x over sine x cosine x equals 4 cosine x minus secant x. Which side looks more complicated? I'm going with left. Left, they both could technically have fractions because secant's 1 over cosine. That's good to know. Keep that in your mind. But I also see sine of 3x, which means I can expand it and also have a bigger fraction. So that's why I'll stick with the left. Guess what I have to do? I have to do exactly what I did last time with the 3x. Split it up. What does sine of 2x plus x become? Sine of 2x cosine x plus cosine 2x sine of x. Now, just to save time, all of that would be over sine of x cosine of x. Would you guys agree? So at that point, would I actually be able to take the numerator and split them with their own denominators? Separate fractions, right? Would that be okay? To say this. And the reason is because what can happen? They cancel. I like that. I like that. So therefore I have sine of 2x over sine of x plus cosine 2x over cosine x. Well, can't I just cancel the cosines and the sines? No. You can't do that. But you can now expand sine of 2x and cosine of 2x. That's 2 sine of x cosine x over sine of x. Hey, that's nice. We'll cancel there. Question. There were 3 options for cosine 2x. At this point, if I cancel all the way over here, how many cosines do I have? I have 2 cosines. I need 4 of them. So I must not be at my answer. But here's the thing. I want this cosine to stay there, don't I? What should I split cosine of 2x to be? We're thinking the third option. So 2 cosine squared x minus 1. Oh, wait. I can cancel then over here. And then it becomes 2 cosine x. But what can I do with that second fraction? Can I split it to its own? 2 cosine squared x over cosine x minus oops, 1 over cosine x. what happens with the cosine x's? That cancels with all of that, leaving me with 2 cosine x plus 2 cosine x plus, or sorry, not plus, but minus secant x. And 2 cosine plus 2 cosine is 4 cosine. Boom. We are happy. So these, we're skipping the lowering of powers. We're doing half angles first so you can actually do worksheet 4. Half angle formulas, if we had a double, we have a half. Each one, again, has their own, except for tangent this time, has 2 options. The question is, where do you want sines and cosines to be? And so, sometimes one is better than the other. Again, the choice for a positive and negative sign depends on the quadrant in which the original u over 2 lies. That's the big kicker right there. You only depends on where the original problem, not the u angle, but the u over 2 angle. Because there would definitely be difference between cosine of 75 and cosine of 150. 75 is 150 divided by 2, so u itself will be 150. So that's what we got to take in consideration. Where does the original problem lie? And that's why, again, our other problem before, when we doubled it, changed it. So, our problem is find the exact value of sine of 22.5. What can you guys say about sine of 22.5? It's the same as 45 over 2. You now know u is 45. And sine has the option of 1 minus cosine 45 all over 2. And now you just use your algebra skills and start working it out. What's the cosine of 45? So 1 minus square root of 2 over 2 all over 2, complex fraction with the square root. Oh my goodness. That's fine. Because now that becomes 2 over 2 minus square root of 2 over 2 all over 2. And that's, inside the same square root, guys. Not losing anybody? Okay. So this becomes the square root of 2 minus the square root of 2 all over 2 all over 2. But isn't that just 2 over 1? What happens when you divide by a fraction? So this becomes the square root of 2 minus 2 all over 4. And when you square root a fraction, you square root the top and the... Yes, you have a nested square root. A square root within a square root. It just happens. You can't do anything else about this. The question is, where is 22.5 degrees? First quadrant. Is it positive or negative? It's got to be positive. Is this going to guarantee you to be positive? I think so. So there is your answer. You now have enough information to do all of worksheet 4. All of it, technically. Now, there's one problem that I'm not going to do because it's not on here. It's the one where I'm asking you, just like the double angle one, where I say, hey, if I tell you cosine is negative 2/3 again, can you evaluate all of these formulas and tell me the sine of u over x over 2, cosine of x over 2? It's in the outline. I'm not putting it on the video because it's the exact same thing. Draw your triangle and fill it in. All right, worksheet number 4 should be able to be a go. We're finishing up the lesson tomorrow. Monday will be a work day for sure. Have a great day.